Okay, our last example is this one. It says a suspension bridge has twin towers extending 50 feet above the road and are 200 feet apart. The cables are parabolic, which means they're shaped like a parabola. Suspend from the tops of the towers and touch the road in the middle. What's the height of the cable 10 feet from the center? Okay, so this one's not area or revenue or anything like that. This one is an actual parabola. The shape of it is a parabola. So what that means is that it is going to be modeled by our general parabolic equation. Okay, so in order to do this, we need a picture because we need to figure out what's going on here. So it says that the bridge has two twin towers. Okay, so two identical towers. They are 200 feet apart. So 200 feet apart. And they are 50 feet tall. Okay, so 50 feet tall. Let me write that a little bit better. All right, 50 feet tall. All right, the cables are parabolic, and they suspend from the tops of the towers and touch the road in the middle. So like this, okay? What is the height of the cable 10 feet from center? So if we were to come, here's center where they touch. If we were to come over 10 feet, what would the height be right there? We've got to figure that out. So what we have to do is we have to figure out the equation of that parabola and then figure out what the height, the F is the height of the cable. And then we've got to figure out what the height would be 10 feet from center. Okay, so we've got to do a little bit of geometry here. So in order to figure out this equation, we've done one of these before, we can also write this as y is equal to a x minus h squared plus k. So this form is the same thing. It might be a little bit easier to think about though. We know that hk is the vertex, and we know that xy is any point on that parabola, and A is the shape of it, but we can't just look at this and know what the shape of it is. So we're going to have to do a little bit of work to find A. Okay, so what do we need? We need the vertex, and we need a point that's on the parabola. So what we need to do is we need to take this picture and we need to put it onto a coordinate axis so that we can figure out some points here, because we need a vertex and a point. So there are a few different ways that you can do this, that you can draw this onto the coordinate axis. But I think the easiest way, or at least the most consistent way, is to just always draw it from the left to the right. That makes all of your x and y values positive, which sometimes makes it a little bit easier to deal with. So if we draw it like this, okay, there's our parabola. I've just taken this parabola right here, and I've transferred it over to our coordinate axis. So let's see if we can figure out some points. All right. We should be able to figure out this one. We know that the towers are 50 feet tall. I can write the 50 over here instead. 50 feet tall, so that would mean that this point has to be 0, 50. Okay, so we've got 1 point. We could also figure out this point because we know that it's 200 across and 50 feet up. So 200 across and 50 feet up. This would have to be 250. Because we know that it's 200 across. Okay, so we've got 2 points on the parabola, but what we really need here is we need the vertex, and the vertex is right here. So how do we figure this one out? Well, it's touching the ground, so that helps a little bit. And then we also need to remember symmetry. Symmetry of parabolas tells us that they are symmetric through the vertex. So if it's 200 feet across, the vertex has to happen at 100. Okay, symmetry of parabolas tells us that. The vertex has to happen halfway across at 100. So we've got 100, and then we've got no height, so we've got 0. So 100, 0 is going to be our vertex. That's our h and our k. And then our x and our y can be either of these points over here. I'm going to use this one because it's got a 0, and 0 usually makes life easier. So we've got our h and our k and our x and our y, and we're going to put that into this equation so that we can find A. We've got to find the missing value. Okay, so y is 50, A is what we're trying to find, X is 0, H is 100, and K is 0. So let's clean this up a little bit. We've got 50 is equal to A times negative 100 squared. That's going to come out, it's going to be negative 100. It's going to come out positive, so we're going to get positive 10,000. Okay, so 100 squared is 10,000. It's going to come out positive. Plus 0, that's just nothing. We can leave that off. We're trying to get A by itself, so we can divide by 10,000. Divide by 10,000. And we get that A is 50 over 10,000. So you can leave this like that. You can reduce it. You can change it to a decimal if you want. Let me see what the decimal would be. The decimal would be 0.005. That might be a little bit easier to work with. But it doesn't really matter what form it's in as long as you get your A and you put it back into the equation. Okay, so I'm going to put it in a 0.005 because I don't have to round that. If you have to round it, it's probably better to leave it as a fraction. All right, and we've got our equation. So just like when we did variation, you're going to have to find A first. Then you can go back and answer your question. I also forgot to put my H and my K in here. Okay, so we've got our A, we've got our H, and we've got our K. So we've got the equation. So Y is equal to 0.005 x minus 100 squared. Okay, because the K is 0. So there's our equation. All right, so we want to figure out what the height is going to be 10 feet from center. So 10 feet from center. So either this way or this way. Doesn't matter which way you go because remember, our graph is symmetric. So 10 feet from center, you're either looking for 110 or you're looking for 90. All right, it shouldn't matter which one you plug in. You should get the same answer either way. So let me come up here and erase this. I have a little bit of room to work. And we're going to plug in, let's plug in 90. Doesn't matter which one you use. So we're going to get Y is equal to 0.005, 90 minus 100 squared. You can clean that up a little bit or you can put that in your calculator exactly how it is. I'm going to put it in how it is. And we should get 0.5. 0.5. So 10 feet from center, our cable is going to be half a foot up from the bottom. So not very much, but it's going to go up quickly as we go to the side.